For E, we've got 3 sine x plus 3 cos. Ooh, don't worry, I did not forget about the double angles. So if you're like, we haven't touched the double angles since, nope, here we are. So yes, you can use substitution where we're using, right, the Pythagorean, right, to sub in. I showed you that on the other examples. We can also sub in double angles. So any of the formulas we have, Pythagorean, so this was not just Pythagorean, but we can use double angles to simplify. Rather you can make it into a double angle if it makes it easier. You can also reduce it into single angles, right? We're allowed lots of different things here. What would be a good strategy here? Can I change this to a double angle? That's not really assigned to x, no. So then can I reduce this to a single angle? Cos 2x. Now, I have 3 possible equations, right? And again, you don't have to have them memorized, but we know one of them is cos squared sine squared. Right, so I'm just bringing up the formula sheet here. So we know one of them is cos squared sine squared. That doesn't look like it's going to be useful because I'm going to get cos squared sine squared. I got a sine and a number here. It's going to look worse, I think. This one has a cos squared, so it'll change this to cos squared, and there's a sine, not bad, but not super useful. This one is sine squared. You could technically go from cos squared to sine squared in 2 steps, but how about if we just sub in 1 minus 2 sine squared for this, and then look what happens again. It's all sine and sine squared, which is quadratic again. And we're back to quadratic, and we can factor. No, not we can. We get to factor and solve and possibly get a bunch of answers again. Okay, so that's the goal. This, we decide that this is the best one to sub in. Okay. Again, these guys will work, but you're going to have to do another sub to get it to simplify to sine. Like if I use this one, then I still have to get rid of this. If I use this one, I still have to get rid of this. This is the best choice. Okay, they'll all work, but that's the best strategy. All right, so let's do that here. So we're going to go 3 sine x plus 3, and then we're subbing in. Again, the other ones will work, but this is faster. So we're going to go 1 minus 2 sine squared x equals 2. Beautiful, beautiful. 1, 2. And we're going to get 3 sine x plus 3 minus 6 sine squared equals 2. Then I'm going to bring everything to the right side. So 0 equals 6 sine squared minus 3 sine x. Bring the 3 over, minus 1. Okay, so you try to factor. Right, 6, 1. Can't factor. You're welcome. Can't factor. Are you going to stop the question? No. If you can't factor, don't give up, don't run away, then, yes, quadratic formula, yay. Right? If you can't factor, then yes, you get to. You could have even used quadratic formula on any of the previous ones, right? So if you couldn't get the 1/2, like factor it this way, you could have done tan x and found that it was 1/2. You could have found that tan was -1. So technically, you could have used quadratic formula for all of these, okay? But factoring is obviously a little bit faster, we hope. But if you really can't factor, you don't stop. You keep going, and you have to solve for x, right? So you have to still solve for x. So write down your quadratic formula, please. Just write it down. You only have to write it down once. So you please write down your formula. So if you write down your formula, you're going to go like this. You're going to go negative b plus or minus b squared minus 4ac all over 2a. Write it on the left side because we are going to have to solve a bunch of things here. So we're going to have to solve a couple things. Okay, so leave room. What did I do wrong here? That's not right. Yeah, what do you think? X equals? Nope, still wrong. Sine x equals, okay, we're used to factoring, right? Because we've got you trained from grade 11. It was sine x. So when you're doing these brackets, tan x, right? It's not x this, x tan, you go here. For this bracket here, when we factored it, it was cos x, right? We're solving for cos x. Here, okay, we're not solving for x. We're solving for sine x equals. So please, 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 no one lose any marks here. It's not jumping to x, it's sine x. So here, I'm going to get sine x. You have to show that. It can't be blank. It always had to have something there anyway because it's a formula, but also it's sine x, not x. Okay, so we know we're not, and you're used to the factoring, right? Because we did that a lot last year, but here, watch out for that. That's tricky. Okay, everyone puts x and then you're done, but you're not. Okay, so sine x, watch out there. Right, so star, 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 be careful. Okay, and please write the formula just once. I just want to see that night's title, and then we go ahead and sub it in. So we're going to do negative, so it'll be 3. You can go right to 3 plus or minus negative 3 squared, 4 times 6 times negative 1. Is that right? And then there'll be 2 times 6. I'm going to go 3 plus or minus root 33 over 12. If you can use this and go straight to your inverse sine and get your 2 answers right away. If you don't, I need you to show extra decimal places. So if I say 2, don't round it to 2 right away because we need another step. So again, if you want to show this steps in between, so keep extra. So one more time, so keep extra decimal places, always. Okay, usually I keep one extra. It seems to be enough to hold the accuracy. You can keep 2 if you want, right? But 1 is enough. So if I get this, I'm going to answer this. I'm going to get sine x equals, and I'm going to get approximately, I got 0.729 for one of them, right? And then sine x equals approximately negative 0.229. So I kept an extra. Does that make sense? I kept an extra. And it's sine x, not x. Right? Don't fall into the trap that you think that that's actually x. A lot of people go, oh, my angle is, that's not your angle yet. Okay, so now we're going to do both of these and cast rule here. So we have to do cast rule for both of them. So we'll take both of these answers here. I'll just draw a little line here to separate it. Okay, so we're going to grab this one over here, and we're going to do x1. Actually, I could probably, I'm just going to drag it over so that you can kind of see. So I'm going to answer this one over here. So for this one, I'm going to get x1 equals approximately, and I did my radian, what did I get? 0.817. Can you guys double check with me? And we're keeping 2 decimal places, but I'll keep 3 until the end. Does that make sense? So 0.817. This is radians. That was not radians. Don't put an R on those. Those are not radians yet. That's the ratio. That's my radians. When I do the inverse, I'm getting 1. And I'm using my cast rule. So it'll be here and here. So then theta 2, or x2, and I did not approximately yet. I'll show the step. Pi minus 0.817 radians, and I'm getting approximately 2.32 radians. You'll stop me if I'm wrong, right? Correct? Okay, I'm going to answer this guy as well. So I'm going to just drag this one over here, if that's okay. Just so I can answer it in a column. If you write small enough, you could have gone underneath. So this one here. I'm going to switch it to beta. Okay, and again, for those students who like to switch it, whenever it's negative, I do the related acute angle and then I fix it from there. Okay, if you don't need to do that step anymore, that's fine, but I'm going to show it. So sine beta is 0.229. Remember, I do the positive, right? Positive. So then beta is approximately, I got 0.231 radians. See how it's like a triple question? You have to do the whole simplifying, and then you have to do two separate questions to answer. So we've got 1, 2. It should be negative, so it should be here and here. Keep going. So then we're going to get x3 would be pi plus 0.231, which would get me 3.37. And then x4, so 2 pi minus 0.231 radians, and I'm getting approximately 6.05. So boy, that CAST rule from last year, we are using it all the time, yes? Okay, and summarize it, right? So I want to see all the answers put together. So therefore, x equals 0.817 radians, 2.32 radians, 3.37 radians, and 6.05 radians. So 1, 2, 3, 4. Any questions, clarification? Okay, so we've got factoring, we've got substituting, we've got changing it to the same thing. Our last example here, one more time, try to look at it before you switch everything to sine and cos. It's okay to switch things to sine and cos, however, try to use a grade 12 lens and go, I'm just going to common factor, then I'll switch it to sine and cos. So it just makes things less complicated right away if you can keep some things as cosecant and stuff. So don't be as afraid. In grade 11, we just said switch it, switch it, switch it. But now kind of go, is it a good idea to switch it, or can I leave it for a little bit? So here, I would just do the common factor first. And I'll switch it later, because I know I will have to. But I would maybe do a common factor first before I just start switching everything. Okay, so over here, I'm going to do common factor cosecant. And then I'm left with secant x minus 2. Right? So rather than substituting in right away and always switching it, I'm going to try to do a little bit of factoring first. Then I can take each one and set each one equal to 0. So, right, each one sets equal to 0. So I'm going to go cosecant x equals 0 and secant x minus 2 equals 0. So that means secant x equals 2 and cosecant equals 0. So then it just gets it all the way down to a single reciprocal ratio, and now I'll flip it. And this just works if you can see something that can be simplified first, right? And I saw right away, it's a common factor. So instead of switching it right away, I thought, I'll common factor, I'll switch it in a minute, right? And so that's why. So grade 12, hopefully you can slow it down a little bit and see when it's a better opportunity to do one thing versus another. Okay, here, if it's cosecant, the easiest way for me to switch it is to do this. I would go sine equals, and I would take the reciprocal of this side, right? And so last year people were like, why are we doing this? Well, because it comes back in grade 12. So we know that's over 1. So the reciprocal of that is going to be 1 over 0. Do the same thing for this one. This is going to be cos equals, and this is over 1. So the reciprocal of this would be 1/2. Does that make sense? Right, so I do the reciprocal after, because I could see it was a common factor, calmed it down, broke it apart, and then now I do this. Right, and what did I do here? this part here, right, is the reciprocal. Does that make sense? So I flip this guy. Okay. Then we want to solve it. But 1 over 0 you can't do, right? It's undefined. So this one here, no solution. Right? If there's no solution, there's no solution. Some people go, is that allowed? Yeah, we just did it on the other page when it equals 2. You go, there's no such answer. Here, there's no such answer. Right? So sine x equals 2, no, not possible. Sine x equals 1 over 0, no, there's never an asymptote in sine. Sine doesn't have one, no answer. So you are allowed to have no solution. We did it on the other page. So you're saying there's no place where there's an asymptote. No, it doesn't work. Okay. Here, is that a special angle? Hopefully, yes, you're recognizing it, right? Adjacent over hypotenuse. So then x equals, and again, if you can see it, you can try it on your calculator. You can go, okay, I know that that is going to be pi over 3. Right, pi over 3. Right, the 60 degrees, and we're going to do pi over 3. And you go, okay, I've got that. Cast rule now. So cast rule for this one would be cos is positive, so it would be here and here. And so then that is my one answer, so that's x1. I already got 1. x2 would be, so it's 5, so we want 6, so 5 pi over 3. Right, so I hope everyone's good with the, remember I said when we first introduced the radians, slice, 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 slice. We keep cutting this into bits. And so 5 pi over 3, and my therefore is x equals pi over 3, or 5 pi over 3. No questions? Verification? Nothing? Okay, are you sad you're done with chapter 7? Sad. Getting there.